NEC Section 200.6 clearly states that the neutral conductor must be white or natural grey. 8/3 and 6/3 tray cable with only black conductors, even if numbered 1, 2, and 3, violates this code requirement. Tray cable is primarily intended for use in industrial and commercial applications where multiple cables are bundled together and installed in trays. It is not typically used for direct burial in residential settings. Using non-code compliant cable can have serious consequences. Firstly, safety hazards can occur. Misidentified conductors can lead to electrical shocks and fires. Secondly, electrical inspections will fail if non-code compliant cable is used. Thirdly, using non-code compliant materials may void manufacturer warranties. It is recommended that you purchase and use 8/3 and 6/3 tray cable with a white neutral conductor. If you find a supply house selling non-compliant cable, notify them of the code violation and request that they stop selling non-compliant cable. If necessary, contact the local electrical inspector or building official to report the issue. It is important to always use code-compliant materials to ensure electrical safety and prevent potential hazards. The National Electrical Code, or NEC, sets the standard for safe electrical installations. Adhering to these standards is essential for protecting people and property from electrical hazards. When choosing electrical cable, it's crucial to verify that it meets the requirements of the NEC. This includes ensuring that the neutral conductor is properly identified with a white or natural grey color. The NEC also specifies the appropriate uses for different types of cables. Tray cable, for example, is designed for specific applications in industrial and commercial settings. Using tray cable in residential direct burial applications can create safety risks and code violations. When installing electrical wiring, always follow the manufacturer's instructions and the guidelines provided in the NEC. If you are unsure about any aspect of the installation, consult with a qualified electrician. A qualified electrician has the knowledge and experience to ensure that the wiring is installed safely and in compliance with all applicable codes. Direct burial cable is specifically designed for underground installations. It has a rugged outer jacket that protects the conductors from moisture, chemicals, and physical damage. Tray cable, on the other hand, is not designed for direct burial. Its outer jacket is not as robust as that of direct burial cable, and it may not be able to withstand the harsh conditions of an underground environment. When installing electrical wiring underground, always use direct burial cable. This will help to ensure that the wiring is protected from damage and that it will operate safely for many years to come. When working with electrical wiring, always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as gloves and safety glasses. Disconnect the power before working on any electrical circuits. Never work on electrical wiring when you are wet or standing in water. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The proper identification of conductors is crucial for electrical safety. The NEC requires that all conductors be identified by color or other means. The neutral conductor must be white or natural grey. The equipment grounding conductor must be green or bare, and the ungrounded conductors must be black, red, or blue. Properly identifying conductors makes it easier to trace circuits and troubleshoot problems. It also helps to prevent accidental electrical shocks. When installing electrical wiring, always follow the NEC guidelines for conductor identification. If you are unsure about how to identify conductors, consult with a qualified electrician. The use of non-code compliant cable can have serious consequences. In addition to safety hazards, it can also lead to inspection failures and warranty issues. Electrical inspectors will typically fail an installation if they find non-code compliant cable. This can delay the completion of a project and cost you time and money. Using non-code compliant materials may also void the manufacturer's warranty. This means that you will not be able to get the cable repaired or replaced if it fails. To avoid these problems, always use code-compliant cable. Verify that the cable is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Check the cable's markings to ensure that it meets the requirements of the NEC. If you are unsure about whether a cable is code compliant, consult with a qualified electrician. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements to ensure that your electrical installations are safe and compliant. You can stay informed about changes to the NEC by subscribing to industry publications, attending training courses, and consulting with qualified electricians. By keeping up with the latest codes and standards, you can help to prevent electrical hazards and ensure the safety of your home or business. The electrical system is an integral part of any building. It provides power for lighting, appliances, and other equipment. A properly installed and maintained electrical system is essential for safety and convenience. When working with electrical wiring, always take the time to do it right. Follow the NEC guidelines, use code-compliant materials, and consult with a qualified electrician if you have any questions. By taking these steps, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes. Consider the ampacity of the conductors, which is the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. The NEC provides tables that list the ampacities of various conductors under different conditions. When selecting conductors for an electrical circuit, it is important to choose conductors that have sufficient ampacity to carry the expected load. If the conductors are too small, they can overheat and cause a fire. The NEC also specifies the minimum size of conductors for various types of circuits. When in doubt, it is always best to choose conductors that are larger than the minimum size required. This will provide a margin of safety and help to ensure that the conductors will not overheat. The voltage drop in a circuit is the decrease in voltage from the source to the load. Voltage drop is caused by the resistance of the conductors. Excessive voltage drop can cause appliances to operate inefficiently or not at all. The NEC recommends that the voltage drop in a branch circuit should not exceed 3% and the voltage drop in a feeder circuit should not exceed 5%. To minimize voltage drop, use larger conductors and keep the length of the circuit as short as possible. You can also use a higher voltage to reduce voltage drop. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuit. An overload occurs when the current in the circuit exceeds the ampacity of the conductors. A short circuit occurs when there is a direct connection between two ungrounded conductors or between an ungrounded conductor and a grounded conductor. Overcurrent protection devices interrupt the flow of current in a circuit when an overload or short circuit occurs. This prevents the conductors from overheating and causing a fire. The NEC specifies the type and size of overcurrent protection devices that are required for various types of circuits. It is important to choose overcurrent protection devices that are properly sized for the circuit they are protecting. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source in the event of a short circuit. This helps to protect people from electrical shock and to prevent damage to equipment. The NEC requires that all electrical equipment be grounded. There are two types of grounding systems: equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to the earth. System grounding connects the neutral conductor of an electrical system to the earth. Bonding is the process of connecting all of the metal parts of an electrical system together. Bonding helps to ensure that all of the metal parts are at the same potential. This reduces the risk of electrical shock and prevents the buildup of static electricity. The NEC requires that all metal parts of an electrical system be bonded together. This includes metal conduits, metal enclosures, and metal equipment. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy electronic equipment. SPD divert the surge current to ground, protecting the equipment from damage. The NEC recommends that SPD be installed in all electrical systems. SPD are particularly important for protecting sensitive electronic equipment such as computers, televisions, and appliances. Electrical boxes are used to enclose electrical connections. Electrical boxes protect the connections from damage and prevent accidental contact with live wires. The NEC specifies the types of electrical boxes that are required for various applications. Electrical boxes must be made of durable materials and must be properly grounded. Conduit is a metal or plastic tube that is used to protect electrical wiring. Conduit protects the wiring from damage and provides a path for the wiring to be pulled through. The NEC specifies the types of conduit that are required for various applications. Conduit must be properly supported and grounded. Wiring methods refer to the way that electrical wiring is installed. The NEC specifies the wiring methods that are permitted for various applications. Some common wiring methods include conduit wiring, cable wiring, and surface wiring. The wiring method that is used must be appropriate for the environment and must be installed in accordance with the NEC. Electrical safety is paramount when working with electricity. Always follow the NEC guidelines and take precautions to protect yourself from electrical shock. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you.